Now start examples here. Start examples about some expansion in solids. A block of a concrete 5.0 meter long expands to 5.00412 meter when heated from 25 degrees Celsius to 100 degrees Celsius. Determine the linear expansivity of the concretes. Now from the question we have something called data. We have length. Before heating, it is original length. That is original length, it was 5.0 meter before heating. That is at that time, at this, it is initial temperature was. It is initial temperature. That is was equal now to 25 degrees Celsius. At this length, it is initial temperature was 25 degrees Celsius. Then it was heated to final temperature. To final temperature. That is this one. It was heated to 100 degrees Celsius. This object was heated to 100 degrees Celsius. Then it is new length becomes, it is new length after heating, that is length 1 becomes 5.00412 meter. This was the new length after being heated to 100 degrees Celsius. Therefore, from here, we have change in length is equal to new length minus original length. That is to say, we have 5.00412 minus 5.0. Now we have 0.00412, that is meter. That is change in length. But from here also, we have change in temperature, final minus initial. Final minus what? Initial. Now, final minus initial, change in temperature is equal to final minus initial. Now, the final minus initial, that is, final was 100 degrees Celsius minus initial with 25 degrees Celsius. Now, the change in temperature will be equal now to 75 degrees Celsius. Therefore, we are looking for the linear expansivity. Now we know from change in length is equal to original length, linear expansivity times this one. Once you make linear expansivity at the subject, we said linear expansivity is equal to change in length over original length and change in temperature. But change in length is 0.00412 over original length. Original length is 5.0 times change in temperature, which now is equal now to what? 75 degrees Celsius. Now we have meter, we have meter. So in short, we have 0.00412 over 5 times 75. Mathematically, once you multiply that one, you get it is 1.1 times 10 power negative 5. That is per Kelvin per degree Celsius, or is equal to 1.1 times 10 power negative 5 per Kelvin. So the point here is to determine linear expansivity. But from the question, we've been given the original length and the new length. We've been given the initial temperature and the final temperature. Then we have to find out the change in length by taking the new length minus the original length. The change, you find it is here. Then change in temperature, it is final minus the initial temperature, 100 degrees Celsius minus 25 degrees Celsius, which is now equal to 75. But we know from this one, I told you this is very important. Change in length is equal to original length times linear expansivity times the change in temperature. We have change in temperature, we have original length, we have change in length. It is therefore making the subject about this one, we have linear expansivity is equal to change in length over original length times change in temperature. We got this one, we got this one, we got this one. Therefore, it is our task to substitute everything that we've been given given by putting this and this and this. Mathematically, it's all about multiplication and divisions. You find it is 1.1 times 10 power negative 5 per degree Celsius or per Kelvin. It is something very important to understand because we have learned the SI unit of linear expansivity on the way that we may explain in that for kind of the way. Have I made myself clear?